Hello YouTube, welcome back to another tutorial of complete .NET Web APIs. So today what I'll be covering up is a quite popular topic, which is pagination, filtering and sorting. So it's quite popular as in it's almost used in every web application. So whenever we pull data using APIs, it has to be rendered in some form of UI, which involves tables with pagination. So let's try to integrate pagination, filtering, and sorting in our API. So we'll start off with where we had left from. We had created CRUD operations on our API for the two tables which we have, which is organization and that is companies and employees. Since then, what I've done is, so what I've done is I've created bulk data entries in the TBL employees table. So I have created around 2 million records, which is just some bulk data to put a lot of load on the system. There are 2 million records in this table. So let's try to run the query on companies and see if we can get the result. So if we check, we are getting the result from the companies table. But if I try the same thing on employees, it should fail because there are 2 million records and it will try to get all 2 million records at one time, and the application will crash or it would take forever loading the records. So if you can see, it's still loading the number of records which we have. So to tackle this problem, what we can do is we can introduce pagination, wherein we instead of pulling all 2 million records, what we can do is we can pull records page by page, wherein each page can have some amount of page size. Page size is basically the number of records which are displayed on one page. Okay. So let's go ahead and do that. So I'll just stop this API. Okay. So now the basic way of achieving pagination is, so if you can see, the way we do it is we have a page number, say page number 1, and we have a page size where one page can show n number of records. So in this case, I'm just taking it as 10. What we usually do is we skip page size into page number -1. Okay. So if the page number is 1, so this is actually page number. So if page number is 1, so this will be 1 minus 1, that is 0 into page size, whatever the page size, so 0 will be 0. So what we'll do is we'll skip 0 and take page size. So in case page size is 1, so we skip 0 records and we take page size number of records, that is 10 records. Similarly, if we are on page 2, what will happen is this equation will come up to page 2, that is 2 minus 1, that's 1, into page size, that is 10 into 1. So what we'll do is we'll skip 10, that is first 10, and then we'll take next 10. So that's how basically paging works. Now, the way we can implement it with our structure where we have dynamic stored procedures is there are two ways of doing it. One is by using something called as offset pagination. So if you see this, this is called offset pagination, wherein you just specify the page number, page size. So what I'm doing is select star from TBL employees and order by paging order. So that was the reason we've created a paging order column, which has a unique non-clustered index. Okay, so what it further does is offset page number -1. So this is basically the syntax for it. So if I run that on TBL employees now and execute this, so you see it gives me the top 100 records. Now, if I say page 2, it will give me next 100 records, which are on page 2. Okay. So similarly, I can keep on going. So page 3 will give me the next 100 records, which are on page 3. But one problem with offset pagination, as you can see, is as we keep on increasing the page number, it takes slightly more amount of time to get the records. So so in our case, there are 2 million records. So if we want records on the 1,000th page, it will take a lot of time to get it. So if I just run this, it will just kind of hang. Also, depending on the amount of load which is there on your database, and if your tables are fragmented, it will take a lot of time. So there's another way of achieving pagination, and that is the way which I usually use, is called key set pagination. So if you see, this is key set pagination, wherein, so what I'm doing is I'm having a page number, I'm having page size, and I'm having the last page number of the previous page. So last page number of the previous page will be again page size into page number -1. So, and what I'm doing is I'm selecting top page size records from the table where paging order is greater than last page number of previous page. Okay, and then order by paging order. So let's try running this. So if you see, I get the results quickly. That is for first row. So if I do the same thing for page number 2, it's almost no difference. So if I do the same thing for page number 100, and if you see, there's no difference for each page, and I'm getting all the 100 records. So let me run for page number 1,000, and see, there's almost visibly no difference. Okay, so this is basically what we'll be using. So now let's get started and start creating the changes in the API for our API to adhere to pagination. Okay, so the first thing what I will be doing is we'll be creating a class called query parameters. So let's go to domain. So let's go to our domain project. And inside utilities, we'll create a class called query parameters. So let me add this class. Query parameters. Okay, let's remove this. I'll call it public class. And let me add 2 private fields here. One will be max page size. So I'm just hard coding it to 100 here for the purpose of demo, but we can obviously keep this configurable in some app settings. And default page size also I'm keeping 100. So page size is basically the number of items in one page. Okay, and maximum page size is maximum number of page size you can specify. Okay, so that also I'm keeping 100. So similarly, we will create 2 properties here. So there will be page number. So default page number will be 1. So if you don't specify the page number, it will always get you the records on the first page. And there will be page size number of records. That is, if the page size is 100, there will be 100 records in the first page. The page size is 1,000, and there will be 1,000 records. So what it is doing is page size, and it is always taking the minimum of page size and max page size. So if the maximum page size specified is 100, and if the user specifies the page size to be 1,000, it will always take max page size. Okay, So now since we have query parameters, the next thing what we will do is uh, let's go to employees now, and we'll create another class called employee query parameters, and we'll inherit the query parameters. So this is basically an abstraction where everyone, all the entity query parameters can inherit from this. So what I'll do is I'll just add another class called employee query parameters. Okay, and I'll declare this as sealed class, public sealed, and I'll get this inherited from, let me rename this. And let's inherit this from query parameters, which we have just created. So these individual classes, that is similarly, I'll also create it for company. Add new class, company. So I've created these classes so that when we have other functionalities like filtering, we can mention the properties on which we need it to be filtered. Query parameters. Okay. So now the next thing what we will do is in our employees controller, we have the get employees method, which is by default getting you all the records. Okay. So what we will do is we will specify a parameter to this. So this get employees, and that is the one which we have just created. That is employee query parameters. We'll just name it as query parameters. Okay. And since this is coming from the query, we'll just specify it as from query. So it will be like coming from query string. So from query. And the next thing is we will need to change the actual implementation in our repositories. So let's go and head to the generic repository which we have. So interfaces, generic repository. And in generic repository, what we will do is we'll change the signature of generic repository, and let's add another parameter here, and that will be query parameters, the class which we have just created. Okay. So now same thing. So since we have created it for generic repository, let's also do the implementation of that inside generic repository. So if we go to generic repository in infrastructure project, so if you see, we'll have a red squiggly here because we've changed the definition of one method, declaration or the signature of one method. So let's change it. So we'll add query parameters here to this method. Now the way we'll use this is, so first of all, what we'll do is our aim here will be to use key set pagination. And that's the reason we'll have to modify our existing stored procedure which we have. And then we'll call that stored procedure with those parameters from here. So I'll just go to the DB project. I'll go to get SP get record. And if you see this, so what we'll be using is, so we'll add two more parameters to this stored procedure. So one will be the page number. We'll default it to 1. And we'll also add a page size. We'll default it to 100. Then we will also add two more items here. One will be the previous page last number. Since we are using key set pagination, it calculates the previous page last number. And then finally, what we will do is we will update the query. So if you see this here, so now it will do, so it will do the same logic, whatever we've done here in key set pagination. So what we'll do is select top, and it will calculate the page size. Rest of the thing remains the same. And here, what it will do is where paging order is greater than previous page last number and order by page order. Okay. So since we have now changed the stored procedure, now in get async, what changes we need to do is we will add the two parameters which we have just added, that is page number and page size. So we'll just add those. It's coming from the query parameters property which we just added. And then the rest of the things will remain same, wherein we are calling the same stored procedure. Okay. So now the next thing which we will do is, yeah, so what I'll do is I'll just execute this stored procedure. I'm not publishing it from Visual Studio because if I do that, it will delete all 2 million records which I have created for testing this. And I don't want to do that. So let me just update the stored procedure from here itself. Okay. Now the next thing which we have to do is let's also create the response DTOs. Now, since we have properties to be retrieved, instead of retrieving all properties, that is, it's always doing select star, we'll retrieve only particular properties that we need from employees table. Okay, so let's do that. So I'll go to DTOs and create a new DTO for employee response. So let me just add a class and name it as employee response. So this is basically a DTO. And we'll quickly add the properties which we need. So if you see, I want the name, age, position, salary, and creation date in my response instead of all items which are there in our actual entity. Okay. So now that's done. So the next thing what we'll do now is in our employee repository, which is the specific repository, we'll have to add a method here. So I will just add that. So that will be, I will call it get employees by query async. Yeah, but before that, I would also want to add another utility here wherein I can display the metadata of paging. So let me just add a class called page list. I'll add it here. Now page list will be like a class which will display a response, but also the metadata about paging, like how many, which page number, how many records, and what is the page size. So all those details each response will have. So let's call it as public, and we'll make it a generic class. And this will have properties like these. So if you see here, we'll have enumerable of items, page number, page size, total count, then has next page, has previous page. So these properties will be helpful when we have a feature like pagination in our web or mobile application, wherein you have to display the number of pages, and also have next and previous buttons accordingly. If there are large number of records, accordingly there'll be large number of page numbers. So to have that functionality, I prefer keeping this metadata along with the response which I send. Now, the next thing what is needed is just create a private constructor. I'll create a private constructor, and I'll take this as the input. I'll take all the items, take the page number, page size, and the total count, which is there in that particular table, which we are fetching from. And now to create the instance of that, I'll create a static method and use this constructor. Since the constructor is private now, it cannot be invoked from outside, and that's the reason we will be exposing a static creator method, or so like this. So we'll take in the parameters from here and invoke the constructor and create the instance of this page list class. Okay, so since we have this now let's go to Iemployee repository and have a specific implementation. So if you see, we had created this uh, specific implementation in generic repositories to have specific queries associated to each entity. So similarly, we'll need to create a specific implementation in iCompany repositories. So for now, for demo purpose, I'm doing it for the employees table. So we'll do it in iEmployee repositories. So if you see, I have a method called getEmployees by query async. And it takes in employee query parameters and not query parameters, but the generic repository, if you see, will take query parameters. So this is taking employee query parameters. And what it is returning is, it is returning page list of employee response. So employee response is the DTO which we have just created, and page list is the generic class which we have just created. So now let's do the implementation for this interface that is in the infrastructure project employee repositories class. So if you just come here now, we should get a red squiggly, and let's implement the interface. So let's call this as async task, get employees by query async. And now let's try to implement that. So what we'll do is we'll query the employees. So employees equal to, we'll call from here, since this is already inheriting the generic repository, we can call the get async method of generic repository, to which we have just made the call to the new stored procedure, updated stored procedure, which we have. Call it as await get async, and we'll pass in the query parameter. So if you see, this now takes two parameters, query parameters, and whichever columns you need, you can specify those as params. So we'll take in query parameters, And the next property will specify all the properties or all the columns which we need to retrieve. So here we'll specify the property names. And if you want to select all the columns, that is, if you wanted to run select star on the table, then you can keep this empty, or you can only specify query parameters here. But I would like to keep the query as concise as possible with only few columns, whatever columns which my DTO needs to display it. Okay, so get async. Now the next is we'll call as queryable, and then what I'll do is I will select, since this will return me records of type employee, I need to convert it to employee response. And that's the reason we'll manually convert it. But later up in the upcoming tutorials, I'll also show you how we can use third-party tools like Mapster to map these directly instead of creating the uh, responses manually. So I'll create new employee response, and we'll just map the properties which we need accordingly. So once this is done, the next thing what I will be doing is creating the page list and returning it from here. Okay, so what I'm doing is just calling the static create method which we have created here. I'm saying page list of employee response and passing all the items, that is the list, the page number, page size, and I'm returning the total number of records in passing the total number of records in the table. Uh, for this demo purpose, I'm just passing this hard-coded value of 2 million. But we can also call another method which can return you the count from the particular table which you want to access. Since getting count of entire table is a very resource intensive call, we can have some mechanism of caching it, because this will be called every time you make the request for every page. So whenever you get every page, it will try to get this. So a better way is to get it once, the records or the count of records in one request, and then have some form of caching and updating it in some kind of background service. So for now, for demo purpose, I'm just showing it by hard coding this total number. Okay. So now, since we've done that, let's go to the controller and update it. Let's see. Yeah. So now the controller will take in. So we've passed in this. So let's change this to, we'll call the method which we have just created. That is to get employees by query async. We'll call this, and we'll pass in the query parameters which we have created. Okay. So the same thing can be done on company's controller. So let me go to company's controller. And instead of calling this here, what I'll do is I'll pass in company's controller. I'll pass company's query parameters, company query parameters. Oops, created it here. So company query parameters from query. Okay, and instead of calling this, we will just have implementation for companies as well. So similarly, whatever we've done for employees, we'll just repeat it for companies as well. So this time it will be company response. So let's also create a DTO for the company. And just quickly have the DTO created for company. Let me call it as company response. Okay, we'll also create this for company. So we'll call this as company response. Get companies by query async. And we'll change this to company query parameters. Okay. And similar implementation, we will have it in the company repositories. So let's go to company repository here and try to implement it. Implement the interface here. This will be public async. This will be company response. And this will be the implementation for companies. So what I'm doing is I just want the name, address, and the country from the company's table. And so this is how I can call the get total count async. Since this is a smaller table, I'll show you how to do that on this table. So it will get the total count async. So we have another method in the generic repository called get total count async, which actually runs this stored procedure to get the records. So I can do it on the company's repository and show it to you because there'll be less number of records in the company table. So let's do that here. And now if I go to company's controller, yes, so we are all set. Let's try to build our application or the API and check if we've broken something. Let's build it. So we have missed something here. Yes, we've missed this implementation. So we'll call this get companies by query async. And we'll just pass in the query parameters here. Let's try to build it again. And the build is successful. Let's try to run the API and try running our endpoints now and see the difference. So we have the Swagger page. Let's first try running the companies. So if you see, the endpoint now has two new fields, page number and size. But if we don't specify anything, it will take by default page 1 and page size is 100, what we've mentioned. We'll just click on execute. And if you see, it gives us the response. And if you see the response now, it is coming in the form of the page list class which we have created. So we have our items here. And as you know, we had specified only the name, country, and address. So it is giving us only those columns. And this is the metadata along with it. Page number is 1, page size is 100, total count, as I've just told you, it is getting from the method which we specified for company. And since there are only 3 records in the table, so if we just check the company's table, there are just 3 records, and 1 record is deleted. So that's the reason the has page next is false and has previous page is also false. So if you have some kind of a UI which is having the uh, next and the previous buttons for the pagination buttons, you can disable them. Okay. So now let's run the similar query on the employees table, which has 2 million records. And let's not specify anything and just click on execute. And you see, so quickly it gave us the records. So by default, it is giving us records from page 1, and the page size is 100. So if you see, there are 100 records here. And now if you see the metadata, there's page number 1, page size is 100, total count is 2 million, has next page is 2, yes, because it has the next page, and has previous page false. Now if I say just specify page number 2, it should get me next records on the next page. Okay, so now you see I have records on the next page. So let me just try running this from Postman and check exactly how much time is it actually taking, because when we just tried without pagination, our application was getting frozen. So it was almost freezing. So now let's try running this in Postman. Let me try for page number 2 now. And let's try the response. So if you see, the initial request took around 2 seconds, and it's getting you 100 records. And there are 2 million records in the table. Now let's see the subsequent pages. So page number 3. And this is because there is a lot of load on my system as well. So page number 4. But it's the average time is quite same. Even if I say page, if I say page 100, the average amount of time remains the same. Okay, so I can also specify the page number here, or the page size here. Instead of getting 100, I can get just 20 records on each page. So if I say page 1, just 20 records, and execute, and this is much faster. Now it's getting me only 20 records. So if I just do this in Postman, it will give you the total time which is needed. So if you see this, this is much quicker, 34 milliseconds. If I get the 1000th page, where each page is having 20 records now. So it's almost similar. So if you run the queries again, so this is pretty quick. So now, since we have implemented pagination, let's move to search, filtering and sorting. So let's go to filtering now. So as you see, we have the employee repository interface, and we have an employee query parameters class. So let's go to employee query parameters class, which we have here. Let's go to domain and employee query parameters. So the property which we need for searching or filtering, I will just add it to employee query parameters. So let's say we want to filter by name. So we'll try to filter by employee name. So I'll add the property here. And then in employee repository, what I will do is I will just do the filtering. So before returning the response, I will just do the filtering, wherein I'll check if the name contains whatever is specified in query parameters. So now if I run this, we'll also have an option for filtering. Okay, so if I go to employees now, pagination, page size, let's add here, we'll save it. Let's see what we are missing here. Let's try to build it again. Yeah. So if you see here, we have another property called name here now. Let's try to filter, let's try to get uh, the first page, and let's try to get 20 records and see what records we have. So we have these records, and I have a person called Sam. I have Jana. So let me try to filter on this A and A. So if I say A and A and try to execute, so it is only giving me this. If I just say A, it is getting me all the records which has A. So if I just use Sam, so it will try to filter based on Sam, and it will just give me a Sam. So we have achieved pagination as well as filtering now. Now let's go ahead and do some sorting. For sorting, what we need to do is we will just go to our query parameters class and add some more properties. So if we go to our query parameters class, I will add another field here called sort order. So I will just mention the sort order default as ASC, which is ascending. Again, this is hard coded for demo purpose, but we can have this configurable in any configuration file or database if you want. And then I'll have two more properties added. One is sort order and one is sort by. If you see sort by, so by default, I will always sort it by paging order, since we have a unique non-clustered index on that. By default, it will sort on page order. And sort order will be, it will be either user specified sort order, ascending or descending. And by default, it will take ascending. Okay. So we've added that here. And now the next thing, what needs to be done is we'll achieve this sorting by using reflection. So we'll just add an extension to the extensions class. So what we'll be using here is, we'll just go to extensions, and I'll just add a custom extension method called order by custom. Okay. So what this is using is, this is basically using expression trees, uh, okay, for ordering. So this is using reflection. So it is passing, it is taking I queryable of I and IDB entity. So whichever entity of ours, so it is taking the queryable, that is all items, is taking the sort by which column we want to sort, and it is taking the sort order. Okay. Now let's go to actual implementation of sorting, which will again be done in employee and company repositories. So after we've put in the filtering logic, let's put in the sorting logic. So what I'll do here is I'll first check if query parameters dot sort by is null. Then I'll check if, yeah, so if you see, I'll first check sort by is null or empty. If not, then I will, since we are doing this in employee repository now, from the employee type, I will try to get the property which is mentioned. So since we'll be putting the name of the property, the user will be specify the name of the property on which he needs the data to be sorted. So it will, using reflection, it will try to find if that property exists or no. If it does exist, then it will call a custom extension method order by custom and pass in the sort by and sort order properties to it. Let me just show you the extension method again. So if you see, it is taking sort by sort order, and based on that, using expressions, it is trying to sort and returning the items which are sorted. Okay, so now let's try and run this again. So by default, it will sort by ascending order. So let's go to employees. So now if you see, there are two more fields added, sort by and sort order. So let's run it as it is. So it will take the defaults for all pagination, filtering, and sorting. So by default, now it is getting us top 100 records from the first page. So now if you see here, to check whether the sorting is working or no, we'll apply the sort on the salary field or salary property. So, so these are all the salaries which we have. Currently, it has ordered by paging order. So what I'll do is I will order by salary ascending so that all these higher value records will go down. So I will say sort by salary, and default order is ascending, so we don't need to mention that. So we'll just execute it. And as you see now the employees with higher salary will be sorted down. So you see, now if I just order it descending, EASC, I will get same items in descending order. Okay. So that's it from this tutorial. So we have successfully implemented pagination, filtering, and sorting. In the next tutorial, we'll be covering another important topic, which is versioning of APIs. So until then, bye-bye.